Hello and welcome to Gauder Acoustic. My name is Dr. Roland Gauder, and today I have with me Mr. Volker Specht, who is our sales manager, and he's also responsible for all the answering the emails in our account. So, Volker, what actually is the most frequently asked question in our mail account?
Well, I don't know if there is one frequently most asked question, but there are actually many questions on basic things about loudspeakers.
Ah, okay.
So sometimes the people want to know, why are you at Gauder Acoustic doing three-way, two-way, four-way, 2.5-way systems? Why don't you do one-way systems? Why do you do sealed enclosures at two-way systems? Why do you do vented systems on three-way systems?
Even worse, high-pass vented systems.
High-pass vented system and all those things that people want to know. So actually, in my opinion, people are really interested in what's behind, what's inside the loudspeaker, what's behind the technique. Why do the guys at Gauder Acoustic do the things the way they do?
Yes, and that's a really perfect question to me, because in my career as a loudspeaker designer, I started with the broadband systems. Actually, in the 60s, we just had our transistor radios, or at home, the big tube radios, and we always had broadband loudspeakers. One speaker for everything. One speaker for bass, mids, and highs.
Yeah.
And actually in the 60s, there was a better way even then, but that's how we all started. And the problem with such a broadband system is that our ear covers 10 octaves.
10 octaves, huh?
Yes, so actually we hear from 16 hertz to 16,000 hertz, and that's a lot. Just in comparison, with the eye we cover 1 octave. From red to blue, but the ear covers 10 octaves, and even worse, the dynamics of the ear is about 60 to 70 dBs without any problem, and the ear just 2 dB, 3 dB. Imagine you wake up in the night and someone switches on the light. That's 5 dBs more, and then you crack. And so actually,
so the ear is much more sensitive than the eyes, huh?
Yes,
much more.
Yes, if you had a newspaper lying on the moon and you light it with one candle, then you can read this newspaper from the earth.
Wow.
If the eye would be as sensitive as the ear.
As the ear.
And so we had the problem that we hear a lot of octaves, big frequency range, big spectrum, and there are no materials available in the universe who are able to reproduce bass, mids, and highs in the same way. Yeah, and even worse, Volker, if you want to reproduce low frequencies, you need a big cabinet, a big driver with a heavy diaphragm, and a small magnet, because in contradiction to what people think, a big magnet decreases the low frequency response. So for low frequencies, you need heavy diaphragm, small magnet.
Small magnet.
But for the highs, for the tweeter, you need a small diaphragm, a very light diaphragm, and a big magnet to create these accelerations you need to resolve these high frequencies. Yeah, imagine. It's 16,000 hertz means 16,000 times per second. Per second. The diaphragm is moving back and forth. And so you can imagine, for a mechanical system, this is just the real limit.
So in simple words, it's not possible to do all the 10 octaves with one driver.
Actually not.
There
is no material in the universe that covers 10 octaves. Yep.
So this leads us to the more-way system.
Yep, multi-way system.
Multi-way system. So let's begin, please. with a two-way system. We have an example here from our range, the Capello 40, a two-way system.
Yeah, actually,
please tell us a few words
about
this.
A few words are not enough because, in my life, I started designing the speakers when I was 12 years old, and we just had the idea that we wanted to have more high frequencies because all these speakers sounded very dull.
Yeah.
And so I bought all my money I got from my birthday, went to an electronic shop and bought a tweeter and a capacitor. And what then happened was really a shock to all of us. We sat there together, 4 boys, and mounting a tweeter in parallel to the broadband speaker.
No, you don't need an exclosure, just put it there.
Just put it on,
yeah.
No cabinet needed, a capacitor in front of it. And we were really shocked when we heard it. There was so much detail, so many details there. There was so much resolution. It was a completely new approach to reproduction of music with this tweeter in addition to the broadband speaker. It was so much more. We all were really shocked. And from that time on, I said, okay, broadband speakers are just okay. But hi-fi, you need to have a tweeter. That's it.
So, Roland, how does, may I say, a common two-way speaker work?
Yeah, a common two-way speaker is just a combination of a 4-inch, 5-inch, 6-inch, 7-inch, 10-inch, even 15-inch woofer with a tweeter.
Yeah.
But as you can see, for a 15-inch tweeter woofer, it would be very hard to reproduce frequencies up to 2,000 or 3,000 hertz.
Yeah, nearly impossible.
Yeah, nearly impossible. So actually, we normally use smaller woofers, 7-inch woofers or 8-inch woofers, to combine them with a tweeter. And so is our Capello 40. That's a two-way system with one 7-inch and one 1-inch tweeter. And the trick here is you have to have a good frequency crossover. But in addition, we also have a roll-off for low frequencies. Of course, it's a small cabinet, it's a 7-inch woofer, and normally you get from 100 hertz down, you get a roll-off, and you have no reproduction here of these low frequencies. And imagine the E string on a bass guitar is 43 hertz.
43, huh?
And 43, that's just 2 octaves below this. And so we just lose a lot of information if we don't have the bass here. Also, we lose the body of the instruments, and also the body of the voices, and so actually that's it's a bit a compromise. A two-way system. You can have a big two-way system, then you have bass, but then you have not the mid's not so good because the woofer.
Then you have a problem here.
Here a problem, and so I said there must be a way we can use it, but not to use bass reflex. Because if you use bass reflex for a two-way system, you have an amplification here on the low frequencies.
Yeah, sure.
But you have a hole in the cabinet, and you have resonances within the cabinet, and they are coupled out through the vent, and you hear all the resonances of the cabinet inside. And that's distorting your mid-ranges. This distorting your naturalness of the reproduction. And so, to my opinion, it's no use to have a vented mid-range cabinet. You should always have a closed, sealed box as mid-range cabinet.
And there comes another opportunity along with this. When you have a sealed enclosure, you can put it everywhere, just in front of the wall, without doing bullshit in the bass.
Yes, of course. There is no coupling to the wall for such a system, and that's good because the bass reflex has this increasing impedance if you come close to the wall, and it starts booming.
But how do you do it? Because you don't want to have a frequency response in the bass like this.
I say, let's take the energy from the amplifier.
Okay.
Our amplifiers have so much energy to produce, and so I say we lower the impedance of our two-way system, increase the current driving the woofer and therefore increasing the acoustical output.
Yeah, because the power of the amplifier today is not a big thing anymore, huh?
Nothing.
Isn't it?
No big deal.
No big deal.
So coming back to the Capello,
Yep.
we have the terminal on the back, and we have two sockets here, which are called bass extension. And with this jumper, we can activate this bass extension. And that's not amplification of bass, but the roll-off is getting lower down to 50 Hertz, like we see it here on this measured curve. Here we have the Berliner RC3, the normal roll-off, like a sealed box. And then the red curve here is the bass extension with the jumper inside. You see it goes down to 50 Hertz linear. So really low bass for such a small speaker. But you can say, okay, this is just resulting in a big hump here, peak. So
maybe sometimes it's too much.
It's too much sometimes, and therefore we invented these bass extension modules. And as you can see here on the curves, the black means the white one.
The white one, yeah.
It's just a little bit peaky, but the green and the blue curve are just close to being linear down to 50 Hertz. And these modules have a fantastic frequency response. And you see, you get all this energy in addition to the normal natural roll-off, and you cut off the destroying and disturbing
subsonic
frequencies and the low frequencies cutting off.
And Roland, in my opinion, important thing, all two-way loudspeakers from our portfolio, so the Dark 40, the RC3, the Capello 40 and the Arcona 40 are doing the same thing.
Yes.
They're all closed boxes and they all use this bass extension.
Yeah.
On top, every loudspeaker has this bass extension, but on the two-way systems, it's really, really a big thing.
For the two-way systems, it's really big, but also for the 2.5 and 3-way system, we will see it's making sense. And you see, it's easy. You plug it in. That's it.
Yeah.
You can do it during listening to music. And so we can really amplify the acoustical output for our small speakers with the help of this high-pass filtering and the bass extension modules. So that's the explanation for our two-way systems.
Okay. So please, Roland, let us talk now not on the 2.5-way systems. Let us start with, at the next step, with a 3-way system. What's better, may I say it in that words, what's better with a 3-way system compared to a 2-way system?
Now, let me explain it with this graph here. We again have the frequency here and the amplitude here. So I start with the mid-range driver because the mid-range driver in a 3-way system is just very close to the woofer. In the 2-way system, it's just reproducing the mids.
Yeah.
And it's in a sealed enclosure. So no venting, no resonances. Then next step is of course the tweeter. And the next thing is the woofer with the bass response. And if you are clever enough to construct a frequency crossover that just gives the right phase and amplitudes, then you have a very good sounding 3-way system. And you see, the woofer is just reproducing bass. Mid-range is only for mids.
What is the frequency we talk about here, the crossover point?
For our speakers here, this crossover point is normally around 135 to 160 Hertz.
Oh, it's very deep, huh?
Yes, a very low frequency. And for the crossover point here, the crossover point here is 3,500 Hertz. But we are very, very low frequency here to change from the woofer to the mid-range.
So this means that a three-way system uses a closed two-way system to reproduce mid-range and highs,
Yes.
and only the bass section
Yes.
is ventilated. So if you take a close look, for example, here at the Capello 100, it's a three-way system, then you have a two-box system inside, which means that the topper enclosure is closed and only the bass is ventilated.
Is vented.
Is
Yes.
vented.
Yeah, yeah, and that's the big thing about a three-way system. I have a special mid-range driver,
Okay.
which should not produce any bass. So it can have a very light diaphragm and a big magnet, a big drive, big magnetic drive. And then I can resolve these high frequencies which a mid-range must reproduce. He goes up to 3,500 hertz. That's
Okay.
a lot for such a
Okay.
70-inch woofer.
And according to the mid-range, you tell us, a three-way system is able to reproduce very, very brighter mid-range
Get more
with
transparency.
much more transparency and much more air inside, I
Yes.
would say.
And the woofer can go down deeper
Okay.
than here with the two-way system. So
Okay.
there are big advantages
Okay.
for the three-way system, but it's the crossover.
Yeah, sure.
It's always the crossover. You need to have a crossover which is right in amplitude and in phase. Otherwise, these signals do not add up. And also, you always have a group delay, which I can also write here, T, the time it takes for a signal to pass through. Then here in the bass, it's like this. Mid-range, and then the tweeter.
So this means that the tweeter is faster
Yes.
than the bass.
Yeah, faster is not the right expression. The right expression is the mid-range is delayed.
Yeah.
The delay. The mid-range is delayed compared to the tweeter.
Yeah.
And this has a lot of problems with the imaging of the speaker and also with the impulse response. And as we always tell, impulse response is much more important than everybody thinks in hi-fi.
Okay, Roland.
Yeah.
You tell us there is a problem with the delay between the mid-range and the highs, and also, of course, with the bass. How do you handle this? What do you do?
Yeah, actually, this problem is just very well known from the 50s and 60s already. And the bigger the delay is, the worse the speaker sounds. And so that's the disadvantage of a two-way system compared to a broadband system. But actually, for me, it's not such a big problem. But of course, we are in high-end, and we should think about this failure in the system, and we should eliminate this failure. And see, there are many of our competitors which do it in a geometrical way.
Yeah.
They
You
push
often see
back
this.
the tweeter, or they have some tilted speakers.
They have tilted speakers,
Yeah,
so
the
they
baffles
have,
are
they have the tweeter a little
like
bit.
this, yes, but actually this doesn't help. This is just a geometrical correction which is not right. But
It helps at
for
in one frequency,
at least, or not at all. And so I thought there must be a way to set up this delay in an electrical way, because then if I delay the tweeter according to this curve, then I compensate all the complete failure in time, and that means impulse response.
A perfect impulse
Yes.
response will be the
Yes,
answer, huh?
absolutely. So the tweeter, the mid-range, and the woofer fire at the same time, and you have a coinciding wave coming up to you, reaching your ears at the same time, and therefore producing a hard attack, a good impulse response. And that's the difference between hi-fi and high-end.
Yeah.
Because this delay means I lose the information about phase, about the room, about the space between the instruments, about the stage.
And this thing gets bigger and bigger the
Yes.
more instruments are playing, huh?
Yes, of course. And if you have the task to reproduce as close to the reality as possible, then if you close your eyes, you should have a realistic image in front of you
Yeah.
for the orchestra, for the jazz band, or for the band itself. And then when you close your eyes, you should say, oh my God, they are standing in front of me. They are right here in the room. And if this is very close to what you feel, then you feel the music in a totally different way than listening to a speaker on the
Yeah.
left and a speaker on the right.
Yeah, this is the thing, yes.
The realism, that's the thing. And the more realistic the reproduction, the better you understand the music.
So you have to take a closer look on those things. So not every three-way system is better than any two-way system.
It's not.
And not every two-way system is better than a how do you say, a one-way system?
Broadband system.
A broadband system, thank you. So you have always, as always, you have to take a close look, because not every 8-cylinder is better than every 6-cylinder.
Absolutely not.
It's the way that you do it.
As the politicians would say, it's the crossover, stupid.
It's the crossover, stupid.
It's the crossover.
So, Roland,
Yeah.
what did we learn about this? This is for me always a very important question.
Yeah,
because
excellent.
and I think I'm not the only one, I want to hear music in the best possible way.
Absolutely. Absolutely. That's the goal we all want to have. Therefore, trust your ears. Listen to the speakers. Forget about two-way, 2.5-way, 3-way, 4-way, or something like this. It's your matter of taste that counts. Listen to the speakers, and your ears will tell you which speaker you like. Forget about all principles, forget about technical data or anything like that. And really just be aware of the impulse response of a speaker, because that's what counts all over the years. If a speaker has a good impulse response, you will always feel the music new. In the first 10 seconds, it's just not so obvious. But in the long run, it's the only thing that counts.
And don't let the system tell you which music you can hear.
Never
Because
do
a good speaker is able to play every
Absolutely.
kind of music, huh?
A loudspeaker is not an instrument. A loudspeaker is an impulse reproducing machine, and it doesn't know which music you play. It just gets impulses and it reproduces impulses. And therefore, it should be able to play any kind of music.
So, thank you for your time and enjoy your trip.
Yes. Thank you very much.
Bye-bye.
Goodbye.